Hi, I'm Jesse with American Radon Mitigation. In this video, we're going to look at activating a passive radon mitigation system. This house was built in 2015 and had a radon level of 2.9. Some of the things we're going to cover are fan selection, pressure field extension testing, the effects of sealing, and energy efficiency. Let's go ahead and take a look and see what's involved. So in June 2009, it became part of the code in Minnesota that every new house has to have a passive radon system. So basically what a passive radon system is a gas permeable layer, which is usually 4 inches of clean rock underneath the concrete floor in the basement. It's got a 6 mil vapor barrier, and then they pour the concrete floor. There's then a 3-inch pipe that runs to that gas permeable layer all the way up through an interior wall of the house into the attic and out through the roof. And then there's supposed to be electrical provided next to that pipe. So in the end, if we want to activate that passive system, we have the electric there already. And that's basically the breakdown of what a passive radon mitigation system is. Alright, so we're up in the attic, and one of the components of a passive radon system is this 3-inch pipe that runs from up on the roof all the way down through the walls of the house and into the basement, and connects to that sub-slab material. So what we've got to do is cut out a section of pipe and insulation where we can add our radon fan. Part of the code is that they have an outlet within 6 feet of the fan, and we've got one right here to plug into. Another thing when activating a passive system is you want to make sure that the pipe is pitched. I checked the pipe on this one and it was not pitched, it was pretty much level. So we've adjusted that so we can get proper drainage for the condensation. So our next step is to add that fan, and then we can go down in the basement and finish up the rest of the components. Our next steps are going to be to drill our diagnostic test holes so we can measure our airflow. We're going to seal the sump because that was improperly installed. And then we'll seal any cracks and openings that we find, and then install our system monitors. Let's go ahead and take a look and see what's involved with that. So the key to getting your radon levels low is to get suction or vacuum under the entire house. So we can make your system more effective and efficient if we take the time to seal any openings to the soil. So on the sump, we've got a huge opening into the soil. This should be sealed, so it's not done properly right now. So what we're gonna do is disassemble all this and put a clear Lexan cover on here. So that's gonna be my next step. So one really important aspect to radon mitigation is sealing. So we want to seal any big cracks or gaps that we find. Typically they're next to the floor to wall joint, so where the concrete floor meets the wall. Often you get a gap there as the concrete cures and shrinks, you'll get that gap that opens up. So we want to seal that. Under the bathtub or shower, often there's an opening there. Sealing the sump is really important. And then to seal the cracks in the floor, we're going to wire brush those to help clean them out. And then we'll take the shop vac and run that over the crack to clean it out. And then we'll use this product called Radon Sealant. So it's a green low VOC product. So we're going to inject that into the crack and then we'll smooth it out with our finger. So in this instance, our suction point is actually on the other side of this wall, and we've got a big gap that we can't get to underneath the sheetrock and the trim. So what we've done is pulled this carpet back, and that'll allow me to get in and inject this small tip on the foam gun. So I've cleaned that out already, I brushed it, vacuumed it. My next step is to seal that with this foam. And then when we're done, we'll put this carpet back. So sealing is really important to help increase the energy efficiency and effectiveness of your radon mitigation system. So what we've done so far to activate this passive system is add the radon fan in the attic. We've sealed any cracks and gaps that we can easily get at. We've sealed the sump cover, which all should have been done by the builder. And we've drilled our test holes, which will allow us to measure the vacuum that our radon system is creating. So we like to put those test holes on the far sides of the house where we know our pressure field extension is going to be the weakest. So now that we've got all of our test holes drilled, they come back to our micromanometers, and this allows us to measure the pressure or suction that our radon fan is creating. We are not measuring radon levels here. The key to getting your levels low is to get vacuum or suction under the entire house. And in a perfect world, if we could have everything sealed up, we would like to get 5 pascals in our furthest, weakest test hole. You can see we don't have anywhere close to that on these 3, but on this one, we're close to our target. So we've got to do a little bit more investigation to see why we're not reaching on that side of the house. So we found we're not quite getting the flow that we would expect. So I've done some further investigation. I cut the pipe apart here, and I took my cable camera and put this down the pipe to see what was going on. And what I've found is I've kind of done a mock-up here of what they've got. So it's just a 3-inch T that's buried below the slab, and then the concrete floor is here, and then here's our 45. So in scoping that, this T is actually filled with rock, and that's creating a lot of restriction, so we're not getting the easy airflow that we should have, because this should be directly connected to drain tile, or at least 10 feet of perforated pipe, so we don't have that resistance to airflow. So the fix that I've come up with is I'm going to core through the floor here with a 5-inch hole, and that'll allow me to dig out the rock around here so we have a lot of surface area to draw from, and it will not restrict our airflow. So that's going to be my next step. So most radon mitigation contractors, when activating a passive system, are simply just going to add the radon fan in the attic, and they're going to add the U-tube monitor in the basement. We like to make sure that the systems that we design and engineer are energy efficient and effective. So that's why we take the time to drill the test holes and make sure that we measure to ensure that the radon system we design and engineer is going to work. So the fan we're using here is a Fantech RN2 EC. The reason we used it because it has a dial in there. We can dial that fan into the settings that we want. So typically this fan would be more than enough to activate a passive system, but you can see we don't have great negative pressure here. Because of the deficiencies in this home with the passive system, we are going to swap it out for a bigger fan, and that should give us the suction that we're looking for. So the really cool thing about these Fantech RN4 and RN2 EC fans is you have the ability to dial them in. So in our weakest test hole, I'd like to have 5 pascals negative. So this is a little overpowered. I can dial that down to achieve the amount of negative pressure I want in this test hole. So we're a little low, so I can crank it up a little bit and get up to my 5. So my last step is to put the screws in the cover here. I'll refluff the insulation in the attic and we can go finish up in the basement. Rachel, we had to replace your old cover because it wasn't sealed properly. So we've replaced it with this Lexan cover, which is nice because it's clear so you can see down in there. You've got an access port here, so you can just loosen this nut up and remove it. So you can reach in there and test your sump pumps to make sure they're still working properly. We've got this secured down, but all the grommets and all that are reusable. You'll just have to reseal it with silicone if you replace the sump pump. One thing that we've also added for you is this water alarm. So if the water gets above your sump pumps where they would normally trigger, it's going to activate this alarm. If that starts to beep, you can hit this button to silence it, and this will also test your alarm to make sure it's still working. So it's just another important aspect of radon mitigation to keep you safe. So Rachel, to kind of give you a recap of what we've done here, is we found a few deficiencies from the build. So up in the attic, the pipe was not pitched properly to allow for drainage, so we had to adjust the pitch on that. And then when we added our radon fan, we found we weren't getting the suction or the flow that we should have. So what we did was actually cut the pipe apart and then ran a camera down there and discovered that all they did was put a T into buried that in rock under the slab. So by code, there's supposed to be at least 10 feet of perforated pipe connected to that, or it's supposed to be tied into the drain tile, which neither of it was. So to fix that, what we did is cored a hole on each side of the suction point and cleaned out the rock. So we took 10 gallons of rock out there. We still weren't getting the flow we needed because the rock that they used was too small, so it didn't allow for airflow very easily. So we added the second suction point to try to get more flow. Up in the attic, we had to add a larger radon fan because one of the other things they didn't do properly would seal up cracks and openings. So that larger radon fan is able to move more air, but the downside to that is your radon system's gonna be louder and it's coming at a higher operating cost. So Rachel, despite all those deficiencies, I'm really happy with the numbers that we're seeing on the far side of the house. So we should have really good radon reduction results here. Here's your radon system monitors. So you've got 2 of them in this case. The first one is just a visual gauge to measure the suction of the radon fan. You want the fluid levels to be different, and that indicates the radon fan is trying to suck this fluid up. So if we pull this tube out, that's gonna simulate your radon system not working. So you'll see these fluid levels be equal at 0. So if you ever see that, make sure you give me a call and we can come out and get it fixed for you. The second one is actually an audible alarm. So if you have a radon fan failure or a pressure change, this is gonna let you know. It's gonna start to beep, and if it does, make sure you give me a call right away. My contact information is here. And lastly, here's an information packet about your radon reduction system. If you ever have any questions, feel free to give me a call. So Rachel, one final thing before we leave is this is your post-mitigation test. This will help ensure that the radon system we installed is gonna keep you and your family safe. So before starting that, you wanna make sure that the radon system's been up and running for at least 24 hours and that you've had closed house conditions for at least 12 hours. We recommend starting the test on a Thursday and mailing it on a Monday, and make sure that you use priority mail to ensure that the test kit gets to the lab on time. And thanks for trusting us to keep you and your family safe. I'm Jesse with American Radon Mitigation. Thanks for watching.